Alright, so welcome back to the next video on the basic properties of sigma notation. I briefly talked about some of the properties in the first video, but we're going to be really diving into some of the properties that will keep being tested commonly throughout the whole entire course of your H2 journey. So I'm just going to list them down and just make sure to follow along and really understand what each property means. Okay, so the first one, when we have a summation, so let's say I have R equals to A. Right? For instance, let's say I have a function which is b times fr over here, where b over here is a scalar. So just know that a scalar multiple can always be brought out, right? It's not supposed to be taken into account when you're actually applying the summation into this. So an example would be, let's say I have 2 times 3 plus 2 times 4 plus 2 times 5, right? It's as good as saying 2 bracket 3 plus 4 plus 5, right? I can just factorize out the 2. And that's exactly what we are doing over here. We are just factorizing out the b over here. Okay, so just take note of that. Now the next one, so this is number 1 over here. Number 2 is that the summation over here, so let's say r equals to a, fr plus minus gr. Right, let's say we have two different functions, and the two different functions are subjected to the same sigma notation, right? We can actually split them over here. So fr plus minus summation r equals to a, gr. Now, why is this useful for us? It's particularly useful when we are dealing with questions that are very big, right? Whenever we have multiple functions within the same sigma notation, it'll be easier for us to break it down, as you'll see in subsequent questions or maybe in your own practice question, right? When you break it down into smaller pieces, it's a lot easier to see the pattern. All right, so that's number 2. Number 3 would be something that I mentioned earlier. Actually, is right. It's quite similar to what I mentioned earlier, and that is, let's say I have a summation over here of r equals to m. Right, fr. So you see that m over here, let's say it does not, okay, I'm just going to put all this to 1 over here to make it more obvious, right? So let's say it does not start from 1, right? For example, let's say r equals to, let's say 3. And what I mentioned earlier is that, let's say if we want to find out what is the sum of t3 plus t4 plus t5 plus t6 plus t7, right? We can technically find what is S7. So this would be t1 plus t2 plus t3 all the way until t7, then I minus away s2, right? Because s2 would be t1 plus t2 over here, and this will give me s2. So s7 minus s2 will give me t3 all the way until t7, right? The summation of all of that. So whenever this is not 1 over here, we can split this up, right? We can split this up to give us n summation of r equals to 1. So we initialize both cases over here to start from 1. So this one would be fr. Right? Then this one would be, I minus away. Now, where do I minus it away from? So I'll minus this away from my m minus 1. R equals to 1 fr. Right? So because you realize that, let's just put an example over here. Right? Let's say I want to find out 7 r equals to 3 fr. I essentially want t3 all the way until t7. So it will be the same as taking t1 all the way until t7 minus away t1 all the way until t2. Right, t1 plus t2 essentially. Because I want to cut away t2 over here, then what's left is from t3 onwards, right? So over here, we will take m minus 1 because we want to minus away until the term that comes right before m1, because we still want m inside the whole entire computation. So it will be m minus 1 over there. Alright, so this is the third, probably the third most common property that you will encounter in this whole journey of sigma notation. Okay, and then number 4 would be a summation of a constant. So for instance, something like that, r equals to 1, and then let's say a, right? If let's say a over here is a constant without variable, okay, I'm just going to write r equals to m over here. So this one would be a plus a plus a plus dot 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 plus a. How many times, right? A total of n minus m plus 1 times, right? Because we start from m and then we go all the way until n. So this would be n minus m plus 1 times a over here, right? And then of course, if the m is 1 itself, let's say this is really 1 itself, here will be 1, and then in the end what you're just left with just an n over there. Okay, so this is the 4th basic property that you will encounter in sigma notation itself. Alright, so there's actually 2 more that I want to go through with you that I will still write on the screen. So I will shrink this. So feel free to pause as we're going through all this to take them down before we actually proceed. Okay, so this is number 4. Now number 5 is looks something very similar, but this is r equals to m. Let's say here's r. So now this r over here is the variable. So essentially we are taking m plus 1 plus m plus 2 all the way until n essentially. So it's essentially an AP, right? It's is as good as saying that this is an AP, because we start from m, then we go up by 1, then we go up by 1, then we keep going on all the way until we reach n. So this is an AP, and therefore, if we were to contextualize the AP formula for this, it will be n minus m plus 1 over 2 bracket m plus n. Right? So beautiful. And why is that the case? It's because this one over here, remember, is the number of terms, right? N minus m plus 1 give me the number of terms. And when I divide it by 2 over here, I get the total number of pairs. So n minus m plus 1 divided by 2 gives me the total number of pairs. And how does each pair look like? Each pair looks like the first term plus the last term. Right? So that's how the whole formula makes sense based off what we know from the AP side. So, but the only other contextualization in this case is that sometimes it doesn't start from 1. So if it starts from m, then that's where you need to actually contextualize it and write n minus m plus 1 over here. So that is for number 5. And then for number 6 would be, to contextualize it, but in the format of a GP. So let's say summation r equals to m a r. So for this case, we are taking am plus am plus 1 plus am plus 2 all the way until an. So this one is a GP because we can see that from here to here, from here to here, we just times the a, we times the a, we times the a all the way. So contextualizing the GP formula that we know, it will be the first term, which is a to the power of m, right? Bracket 1 minus, and then your constant is a, right? Or your constant ratio is a. Now, how many times does this constant ratio being applied? You count the number of terms that you have. So over here you have n, m. So the total number of times is n minus m plus 1 over 1 minus a over here. So this is how you actually contextualize it, right? Based off the general formula that you know from earlier on, right? This one is your first term. This one is the total number of terms. And then you just contextualize it as such. So these are the 6 basic properties. Any other properties that they want to test you, like a more novel kind of property, they have to give it to you in this syllabus. But these 6 are the ones that you're expected to know by heart, right? They can give you other properties of sigma notation. The whole world of sigma notation is very big, right? But these 6 are the most basic ones. And if they want to test you anything else, they must give it to you. Okay, so I won't go through the ones that are not the 6 most basic ones because I don't want to overwhelm you. But just know that if the question wants you to use another sigma notation, right, that you have never seen before, or maybe it's like something more novel, right, they have to give it to you. And then you use these 6 principles, these 6 basic properties to answer that question and, manipulate that sigma notation property. Okay? So otherwise, this is the example question that we're going to try now. Feel free to pause this video right now to tackle these questions. And if not, we will actually start going through these questions together right now. Alright, so let's tackle these questions right now. For the first one, over here, we can see that we have 2 times r, right? 2 is a scalar. So we can actually bring the 2 out. And that will give us 2 summation of r equals to 1 and then r here. And then we know that this is essentially just 1 plus 2 plus 3 plus 4 plus all the way until n, right? So it's essentially an AP. So we know that this will give us 2 times how many pairs are there, right? So it will be n, 1. So it's n minus 1 plus 1 divided by 2, with the first term being 1 and the last term being n. So to conclude, this will give us n times 1 plus n, and that's just n plus n squared, right? So this is the final answer for the first one. It's just recognizing that this over here is an AP. Okay, moving on to the next one. This over here is very clearly a GP because the power is the one that is being varied, right? So we have half to the power of 0, half to the power of 1, half to the power of 2, all the way until half to the power of n. So this is a GP. And since this is a GP, for B, we can just use the GP formula that we already know. So that would be my first term. So it's half to the power of 0. That's the first term, right? 1 minus half to the power of, how many terms are there? N minus 0 plus 1, right? N minus n plus 1 over 1 minus half. So this essentially will give me 1 minus half to the power of n plus 1 over half, which simplifies to give us 2 bracket 1 minus half to the power of n plus 1, right? Which is the final answer to part B over there, right? So first part is recognizing it's an AP, second part B is recognizing it's a GP. Now for part C, you realize that it's also a GP, right? Because this one is also a GP. But there's a plus 2 over here that we must split at the start. We need to split this into the summation of 2 different functions so that we can isolate this as a GP on its own, right? So therefore, this one over here, we'll first split it up to give us r equals to 1, 5r plus 2n r equals to 1, 2. Then from here, we know that this is a classic GP, right? This one is just a classic GP. So this one would be my first term, which is 5 to the power of 1, bracket 5 to the power of 2n minus 1 plus 1 minus 1 over my constant ratio of 5 minus 1, essentially, right? So that one would be for the first GP, right? 2n minus 1 plus 1, 2n minus 1 plus 1, right? The number of terms. And then this one over here is a constant. So this is a constant that is being added 2 plus 2 plus 2 plus dot 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 plus 2. How many times? 2n minus 1 plus 1 times. So essentially that's just 2n times. So you plus 2n of 2. So when you expand this whole thing over here, you will get a very nice value of 5 bracket 5 2n minus 1 over 4 plus 4n. And then of course you can further simplify this over here to give you 5 2n plus 1 minus 5 over 4 plus 4n, which gives you 5 2n plus 1 over 4 minus 5 over 4 plus 4n. And that's the final answer. Okay, so part C is just recognizing it's a GP as well, but before that you have to split it up. And then for the last part, right, how do we actually tackle this? This looks so complicated, right? But the truth is that there's a small little difference over here that makes it very, very easy, right? Is that you realize that all the alphabets inside here are capital letters, whereas this over here is a small letter. So this over here is supposed to be the variable, right? Small n is the variable. But inside the general term over here, this is capital N, right? And we know that capital N is not the same as small n. So since they are not the same, what does that mean? That means this over here does not apply to this. Does not apply to this. Because the small n cannot sub into the position of the big N, right? So it does not apply. And since it does not apply to it, what we do is that we take this whole thing over here and we treat this like a constant. So the answer to this is very simple. How many terms do I have? I have big N minus 2 plus 1. So minus 2 plus 1 of the constant of n minus 1 minus e to the power of n, which eventually just gives me n minus 1, 1 over n minus 1 minus e to the power of n as the final answer to this question over here. Okay, so just take note that, the alphabet size matters, and as long as you are slightly more careful, you realize that after you do a bit more practice, sigma notation becomes very, very easy. So any other questions, let me know in the comments below. If not, you want to check out more questions, more exam style questions in my library of recordings I have, make sure to check out the link in the description below as well if you want to get access to that. If not, I'll see you in the next video for the next concept.